For our second example, we want to graph one period of the function y equals 3 sine of the quantity 2x plus pi thirds. So in this case, we have the same sort of job as before when we're starting with what happens to those values a, b, c, and d. We have that here, a is 3 again, so our amplitude, the absolute value of a, remains 3, while our period here will be 2 pi over b, but in this case, 2 pi over b is 2 pi over 2, or pi. And here, we actually do have a phase shift, where our phase shift is going to take the form c over b, because we've got to factor out that 2 from the pi over 3. Here, that would take form pi over 3 over 2, or pi over 6. So our whole graph is going to be pushed a little bit away by pi over 6 units. And from here, we can move on to our second step, where we want to get our 5 points. Because our period is pi, our quarter period is going to end up being pi over 4. And our starting point, x1, is determined by the phase shift, which here is pi over 6. So taking that pi over 6 and adding to it pi over 4 repeatedly, we will get for x2, 5 pi over 12, for x3, 2 pi over 3, for x4, 11 pi over 12, and for x5, 7 pi over 6, following a series of small fraction simplifications that, for example, if you add pi over 4 to 5 pi over 12, you're adding 3 pi over 12, which means you get 8 pi over 12, and you can divide out of 4 to get 2 pi over 3 for x3. It's the same idea for any of them. But once you've got those values, you can then turn the values into the tables that we need in terms of our function. And I misspoke when I said 2x plus pi over 3. It should be 2x minus when I said that. Apologies. Anyway, for this, we're going to be plugging in values of pi over 6, 5 pi over 12, 2 pi over 3, 11 pi over 12, and 7 pi over 6, where at pi over 6, we would have 3 sine of 2 times pi over 6 minus pi over 3, which becomes 3 sine of pi over 3 minus pi over 3, or 3 sine of 0, which is 0, because sine of 0 is 0. Meanwhile, at 5 pi over 12, you're going to plug that in. It'll turn into 3 sine of 5 pi over 6 minus 2 pi over 6, or 3 sine of pi over 2, which is just 3. At 2 pi over 3, we would get 3 sine of 4 pi over 3 minus pi over 3, which here would leave us with sine of pi, again 0. And at our last 2 points, 11 pi over 12, you simplify that out and you get 3 sine of 3 pi over 12, which is negative 3. And then finally for 7 pi over 6, you would plug that in, get 3 sine of 2 times 7 pi over 6 minus pi over 3, which would be 7 pi over 3 minus pi over 3, or 3 sine of 6 pi over 3, where sine of 6 pi over 3 is sine of 2 pi. 0 times 3 is 0. Long and short of it is you get the points. Pi over 6, 0. 5 pi over 12, 3. 2 pi over 3, 0. 11 pi over 12, negative 3. And 7 pi over 6, 0. Where here, because we don't want to deal with step 5 to get a bigger graph, we just want one period, we can use this information to make a picture like this, where we can see again that period of 3, that our phase shift has pulled the graph over pi over 6 units to the right, and has made the graph a bit thinner from that value b, that our period is just pi instead of 2 pi. It's been cut in half. And from here, we're going to talk about how we can handle similar things, but instead dealing with the cosine function, where all of these same patterns still hold, it's just they're adjusted a little bit for the new design.